So, we're going to go over LUTs. What is a LUT? A LUT, or a lookup table, is a document containing a table of values that are looked up by the software that you're using, in this case DaVinci Resolve, and are used to translate an image from one set of color values to another. Doing this, a LUT can translate an image from one gamma and color space to another, attempt to shortcut creative grading, or even make sure that a reference monitor is giving a more accurate image. We can use LUTs in the grade for a number of purposes, both technical and creative. We'll go over the main examples. Calibration LUTs. This is a super important one in facilities and high-end industry. A calibration LUT is used to make an external reference monitor display colors within a given color space correctly. So, for example, a calibration LUT can be used to compensate for known display errors in a monitor to ensure that it accurately represents Rec. 709 for delivery to broadcast. This is one important thing I can't really incorporate into this course, as I can't give a proper demonstration of this without you being in the room. Technical LUTs. These are intended to translate an image from one color space and gamma to another. This then attempts to ensure that the image comes out the same, looking correct, in multiple playback scenarios. For example, we have a video meant for web and also for broadcast. We don't make two separate grades. We grade to one standard first, in this case it would be broadcast, as that is where the color accuracy would be the most important due to things like AQC, which we will cover later. After that, we can apply a LUT that translates our image from gamma 2.4, which is appropriate for broadcast, to gamma 2.2, which is appropriate for web. We then have a single graded video stream that we can translate to fit multiple viewing scenarios. We can use LUTs like this to prepare an indie feature film for a DCP packet using a Rec. 709 to P3XYZ LUT, for example, while still being able to deliver the same stream, sans LUT, to broadcast. We can also use technical LUTs to make a HDR timeline SDR as well. Display LUTs. One of the most common usages of the LUT is the display LUT. A display LUT changes the image shown on a monitor without changing the source footage that is being displayed. A display LUT is loaded into a monitor or camera, and then, when shooting, you get an image that looks normal and makes more sense to the eyes of all involved than a flat image in log. Together with creative LUTs, these ones can start an argument depending on your DOP. A display LUT aims to give you a good approximation of a finished image whilst capturing log footage. Now, here's the thing. Plenty of people out there think a LUT like log C to Rec. 709 is a one-size-fits-all. That's not accurate. A LUT is essentially a preset color transform. It was made with a certain set of conditions in mind, lighting, etc. So if you take your LUT into a different lighting setup or daylight changes over the course of a shoot, then it's not going to produce the results that you might be after. ARRI provides a LUT generator that allows you to change the way the LUT behaves. The real trick to display LUTs is to get a good gel between your exposure and a LUT intended for your lighting conditions and camera. Display LUTs are very important because it's very easy to accidentally badly expose an image if you're monitoring in log, as log leaves a good chunk of the tonal range empty in its ideal exposure. A display LUT can be supplied to the colorist to assist with the grade, and we will cover that in a later lecture. These LUTs are shortcuts to a creative look during the grade. Now, I don't use these very much, as the cold, hard reality is that any preset look will produce variable results with real-world footage that was not shot with that particular preset in mind. Together with the fact that a LUT cannot actually carry any secondary grades, this means that LUTs that go for more stylized looks are actually a pretty blunt instrument that rely on balancing primary grades in order to get close to something like a traditional teal and orange color contrast. These kinds of LUTs are popular with indie filmmakers who are starting out, as they can give a head start when going for something that looks sophisticated, but the truth is a real grade is always going to outperform these. That being said, some of the film print emulation LUTs are quite useful when going for the look of a particular print film stock. This was a good intro to the main uses of lookup tables. In the next lecture we're going to look through how we might use a LUT in the grade, and when it's appropriate to do so. Click on through to the next lecture when you're ready. In this lecture, we're going to take a look at the application of LUTs within Resolve itself. We've got some log C footage to use here, and we can approach this a number of different ways. We can grade the raw footage from the ground up, and I quite like doing this, or we can apply a LUT in a few different places to ensure that we've got an accurate translation from log C to Rec. 709. First, we can apply an input LUT. This applies a LUT and its transformations right at the start of our pipeline. This means that our RGB input, the little green dot here, then represents the image with the LUT applied. It will happen before everything else. To do this, we click on the little gear in the bottom right, choose the Color Management settings, and scroll down to the menu headed Lookup Tables. Here we have several dialogues that let us apply 1D or 3D LUTs in a number of different places. We can select our 3D input LUT and then choose Log C to Rec. 709. Now, before anything else happens to our image, the LUT has taken the values and translated them so that they are accurately represented when shown in Rec. 709. We can now close this window and go ahead and grade our timeline. There's a catch though. This LUT has been applied to every clip on our timeline, and we have source from multiple cameras in this project. If we go to another clip, this is not an appropriate approach here, as making a log C to Rec. 709 transform on footage that is not log C is not appropriate. We'll go over how to approach this in a minute. Next, we can apply an output LUT. This applies all the color transforms right at the end of the pipeline, and this dramatically changes the way our image responds to our adjustments. To do this, we go back to our color management settings and choose 3D output lookup table, and here we'll go for log C to Rec. 709. Now, doing this technically gives you a little more leeway with your image. However, a lot of colorists find that they just don't like the way grading feels when using LUTs like this. You can try it yourself. It's awkward, things wrench around and compress when you don't intend them to, and it can take quite a lot of practice to get used to this. You can see if I put things down, they're not really clipping or flattening out, they're kind of compressing, and it just looks very different. It feels very different. This also has the same issues as applying an input LUT. It will sit on top of the whole timeline and not discriminate between clips. These two approaches are typically only good for single camera projects. A more flexible way of doing this is to apply LUTs to nodes in the node tree. This is easy to do. Just right-click the node, go to LUTs, and then mouse to the LUT that you actually want to apply. In this case it's a 3D LUT and the ARRI log C to Rec. 709. We can now place the LUT and its transforms anywhere we want in our pipeline, and of course this only applies to the affected clip. Using this in conjunction with grouped shots is a great way to keep a multi-camera project under control. So now that I've got this here, what I can do is put a node before and after, and I can just do a little cleanup. So let's just prevent anything from clipping when the LUT gets involved. On this first node, and then on the node afterwards, we can then go back and sort out our basic primary when it'll then behave more like the way we want it to. That's more like it for a basic primary grade. So we just make sure that nothing clips or crushes. We even out our distribution of values in the first node, then we have a LUT, then the next one we do our standard primary grade. Although, to be honest, especially on simple projects like this, you can just forego the LUT and then just do a primary grade from scratch. We can also right-click on a clip in our right-click a clip in our clip list and apply the LUT directly to that clip. Doing this is the same as applying an input LUT, but only to the selected clips. We can select multiple clips this way and apply LUTs for a multi-camera project. Finally, we'll go over how to export and install a custom LUT into Resolve, so you can then apply it at your discretion. Any primary grade or collection of primary grades can be exported as a .cube or Panasonic VLUT. To do this, simply right-click on the thumbnail of the clip with the desired grade and choose Generate 3D LUT (cube). Once we've done that, we can then choose where to save it, and we can save it directly into Resolve's LUT folder, but for now we're going to put it in a dedicated folder and we're going to install it manually. Now we need to navigate to Resolve's LUT folder, and the easiest way to do this is to open our project settings and click the Open LUT Folder button. Now just paste the LUT into the appropriate place, and you can even create a new folder to keep your new LUTs. After that, we hit the Update Lists button. And now, if we want to apply our lookup table, we see we have our new folder, Demo LUTs, and our new Demo LUT there, and it recreates our primary grade perfectly. This has been a good overview of how and where to apply lookup tables. We'll go over the important difference between 1 and 3D LUTs in the next lecture, and then we'll be ready to take on our next real-world project. Click on through to the next lecture when you're ready. Okay, let's go over the two main kinds of LUT you'll be using within Resolve. Whilst LUTs have different intended functions, we also have two main types of LUT to contend with. The first is the 1D LUT. 1D LUTs are only capable of taking single original values and remapping those to single output values. So for example, if our input value is 12, we could make a 1D LUT that remaps the value of 12 to 56 or to any other number. Now, we have 3 color channels in RGB color space, and a LUT that can only work with a single set of values is going to be incapable of working with all 3 channels. Because of this, 1D LUTs are only capable of changing gamma. If we take a set of input values from a known gamma curve, we can write a LUT that translates those values to reflect their appropriate place on a different curve. So, by applying this 1D LUT, we can change the gamma of an image from one curve, such as Canon log, to another, such as Rec. 709. This has its uses, but it's a bit of a blunt instrument, and because 1D LUTs are so heavy-handed, we tend to only use them at the start of a project, if at all, to set the gamma for our grade. I'm going to be honest with you, I've barely ever had call to use 1D LUTs myself. Nowadays, I get much more mileage out of Resolve's color management settings, which are much better. The next type, which is much more useful, is the 3D LUT. 3D LUTs can take output values from all 3 color channels in an image and remap those accordingly. Now, this gets complicated. 3D LUTs contain a few shortcuts because if they had a definite value for every single RGB combination, which is referred to as an RGB triplet when we're talking about this kind of thing, then the LUT file would be too large to use practically. Because of this, 3D LUTs generally contain a smaller number of reference points and then interpolate the remaining values, which does introduce the issue of minor color inaccuracies when using them. Despite this, they are typically more valuable than 1D LUTs. 3D LUTs are used for all kinds of things, like translating images from one gamma or even color space to another, setting the contrast and creating stylized looks themselves, and calibrating for external reference monitors. I've even used LUTs to take images in and out of HDR for some clients. A good input LUT can give a great helping hand to a DOP who wants an indication of the final look of their project whilst shooting. These can range from simple log to Rec. 709 LUTs, all the way to LUTs that attempt to approximate a final grade. Now, because a pre-made LUT is extremely unlikely to be suitable for lighting conditions that couldn't possibly have been predicted at the time of its creation, we can generate custom LUTs on the fly using Resolve whilst we're on shoot. We can do this quite easily. First, we get some test footage into Resolve, and I've gone back to our dialogue sequence here. Then, we perform a grade on one of the clips that we receive and export a custom LUT like we did in the previous lecture. We can then send that to the DOP on a memory stick and they can load that into their camera. This will give them a much better idea of what they're shooting before they reach the grade. Now, a big point here. 3D LUTs cannot reproduce an entire grade by themselves. If you've used any secondary corrections, then tough luck, they won't be carried over. If we apply the LUT we've made just here, then you can see that it's missing the secondary corrections we had before. This is something to keep in mind and remind others of, particularly if you get a DOP who insists on using the LUTs they've used in shoot. Just remind them that the most accurate parts of the process are excluded by these things. This was a good overview of the two main types of lookup table you're likely to encounter. Now we're moving on to the next real-world project. Click on through when you're ready.